According to your understanding of Article 511.2, an automobile showroom used for the parking and storage of vehicles, where no repair work is performed that requires the use of electrical equipment, open flames, welding, or the use of volatile flammable liquids, is not considered a classified area. Therefore, the elevation of receptacles in such a showroom is not subject to the restrictions outlined in Article 511. Receptacles can be located at any elevation as permitted by other applicable codes and standards. Regarding wiring, Romex, also known as non-metallic sheath cable or NM cable, is generally not permitted for use in garages due to its susceptibility to damage from vehicular traffic and potential ignition sources. However, in the specific case of an automobile showroom that is used solely for parking and storage without any repair work, the use of Romex may be acceptable because it is not exposed to the same hazards as it would be in a typical garage environment. The determination of whether Romex is acceptable depends on several factors, including the specific use of the showroom, the presence of any potential hazards, and the interpretations of the local authority having jurisdiction. To ensure proper compliance with electrical codes and standards, it is always advisable to consult with a qualified electrician and the local authority having jurisdiction. They can provide specific guidance and approval based on the specific conditions and use of the automobile showroom. The National Electrical Code, or NEC, provides guidelines for electrical installations, but local codes and interpretations can vary. The authority having jurisdiction is the local governing body that enforces these codes. When evaluating the use of Romex in an automobile showroom used only for parking and storage, firstly consider the physical protection of the cable. Non-metallic sheath cable is more vulnerable to physical damage than metallic conduit or other types of protected wiring. In areas where vehicles are moving, or where there is potential for the cable to be struck or damaged, it should be protected with conduit or other appropriate means. Secondly, assess the environmental conditions. Although the showroom is not considered a hazardous location, factors like humidity, temperature, and exposure to chemicals can affect the lifespan and safety of the wiring. Standard Romex is suitable for dry locations. If the showroom is subject to moisture or corrosive elements, a different type of cable or wiring method may be more appropriate. Thirdly, consider the building construction type. The National Electrical Code distinguishes between different types of building construction, and these distinctions can affect wiring requirement. The construction type can influence the allowable wiring methods and the need for additional fire protection measures. Fourthly, ensure proper support and securement. All wiring must be properly supported and secured to prevent strain on connections and to protect against physical damage. The National Electrical Code specifies the maximum intervals for support and securement, which must be followed. Fifthly, pay attention to ampacity and conductor sizing. The conductors must be sized appropriately for the intended load, and the ampacity of the cable must be sufficient for the circuit. Factors such as ambient temperature and the number of conductors in a raceway or cable assembly can affect the ampacity. National Electrical Code Table 310.15 B16 provides ampacity ratings for various conductor types and sizes under specific conditions. Sixthly, ground all metallic enclosures. Any metallic enclosures, such as junction boxes or equipment cabinets, must be properly grounded to provide a path for fault current and to minimize the risk of electric shock. The grounding system must comply with the requirements outlined in Article 250 of the National Electrical Code. Seventhly, consider future modifications. Electrical systems often require modifications or additions over time. When installing wiring, consider the potential for future changes and ensure that the system can be easily expanded or modified as needed. Eighthly, install arc fault circuit interrupters, RF size, and ground fault circuit interrupters, or GFCIs. The National Electrical Code requires the use of arc fault circuit interrupters in many locations to protect against arc faults which can cause fires. Ground fault circuit interrupters are required in locations where there is a higher risk of electric shock, such as wet or damp locations. Ninthly, ensure proper labeling and identification. All circuits and equipment must be properly labeled and identified to facilitate maintenance and troubleshooting. The label should clearly indicate the purpose of each circuit and the location of the corresponding overcurrent protection device. 10th, comply with all applicable codes and standards. Electrical installations must comply with all applicable codes and standards, including the National Electrical Code, as well as any local amendments or regulations. It is important to stay up to date with the latest code requirements and to ensure that all work is performed by qualified personnel. Given the nuances of electrical installations, consulting with a qualified electrician and the authority having jurisdiction is paramount. These professionals can assess the specific conditions of the automobile showroom, provide accurate guidance, and ensure that the installation meets all applicable codes and standards. Always prioritize safety and compliance when working with electricity to protect against hazards and to ensure the long-term reliability of the electrical system. The type of electrical wiring used in a building is governed by the National Electrical Code, which is updated every 3 years, and local amendments that can vary based on the state, city, or county. Common wiring methods include, firstly, non-metallic sheathed cable, which is also known as an M cable or Romex. It consists of 2 or more insulated conductors inside a non-metallic sheath. It is typically used in residential buildings and some commercial applications for branch circuits and feeders. Secondly, metallic conduit. There are several types, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Metallic conduit provides excellent protection for conductors and is often used in commercial and industrial settings. Thirdly, armored cable or AC cable, which consists of insulated conductors wrapped in a flexible metal sheath. It is often used for branch circuits in dry locations. Fourthly, mineral insulated cable or Mi cable, which consists of conductors insulated with a mineral compound and encased in a copper or stainless steel sheath. It is used in high-temperature environments and hazardous locations. Fifthly, cable tray systems, which are used to support insulated conductors or cable assemblies in industrial and commercial buildings. Cable trays can be made of metal or non-metallic materials. Sixthly, direct burial cable. It is designed for underground installation without the need for conduit. It has a rugged outer jacket to protect against moisture and physical damage. When selecting a wiring method, consider factors such as, firstly, the environment. Wet, damp, or corrosive environments may require special wiring methods. Secondly, the type of occupancy. Different types of buildings have different electrical requirements. Thirdly, the voltage and current ratings. The wiring method must be suitable for the voltage and current of the circuit. Fourthly, the mechanical protection. The wiring method must provide adequate protection against physical damage. Fifthly, the cost. The cost of materials and labor can vary significantly between different wiring methods. Electrical receptacles, also known as outlets, are points in the electrical system where devices can be connected to receive power. The National Electrical Code specifies requirements for the installation and placement of receptacles to ensure safety and convenience. These requirements include, firstly, spacing. In dwelling units, receptacles must be installed so that no point along the wall line is more than 6 feet, or approximately 1.8 meters, from a receptacle. This ensures that extension cords are not needed to reach most locations. Secondly, small appliance circuits. In kitchens, dining rooms, and similar areas, at least 220 amp small appliance branch circuits are required to serve receptacles for countertop appliances. These circuits must not serve other outlets. Thirdly, bathroom receptacles. At least one receptacle must be installed in bathrooms near each sink location. These receptacles must be ground fault circuit interrupted protected. Fourthly, outdoor receptacles. Receptacles installed outdoors must be weather resistant and must have an enclosure that is suitable for wet locations. Fifthly, garage receptacles. At least one receptacle must be installed in each attached garage. These receptacles must be ground fault circuit interrupted protected. Sixthly, receptacle height. The National Electrical Code does not specify a minimum height for receptacles, but local codes may have requirements. In general, receptacles are installed at a height that is convenient and accessible. Seventhly, tamper-resistant receptacles. The National Electrical Code requires tamper-resistant receptacles in dwelling units to protect children from electrical shock. Eighthly, dedicated circuits. Certain appliances, such as refrigerators, washing machines, and electric dryers, may require dedicated circuits to ensure proper operation. Ninthly, ground fault circuit interrupter protection. Ground fault circuit interrupters are required in locations where there is a higher risk of electric shock, such as bathrooms, kitchens, garages, and outdoors. Tenthly, arc fault circuit interrupter protection. Arc fault circuit interrupters are required in many locations to protect against arc faults which can cause fires. When installing electrical receptacles, it is important to follow all applicable codes and standards. Consult with a qualified electrician to ensure that the installation is safe and compliant. The authority having jurisdiction is responsible for interpreting and enforcing the National Electrical Code and local electrical codes. This authority could be a local building inspector, electrical inspector, or other official. It is important to work closely with the authority having jurisdiction to ensure that electrical installations comply with all applicable requirements. The authority having jurisdiction has the power to approve or disapprove electrical installations and to require corrections if violations are found. They can also provide guidance on specific code requirements and interpretations. In order to ensure compliance, it is essential to firstly review the National Electrical Code and local electrical codes. Secondly, submit plans for approval before beginning work. Thirdly, schedule inspections at various stages of the project. Fourthly, address any violations promptly. And fifthly, maintain accurate records of all work performed. Working with the authority having jurisdiction is an important part of ensuring electrical safety and compliance.